Imagine rolling two identical cans down a slope, but one is empty and the other is full. Which one will reach the bottom first? You might have learned that when dropped straight down, all objects fall at the same rate regardless of how heavy they are, neglecting air resistance. Is the same true for objects rolling down a hill? When you lift an object up the ground, it has potential energy due to gravity. The amount of potential energy depends on the object's mass, the strength of gravity, and how high it is off the ground. When you drop the object, this potential energy is converted into kinetic energy, or the energy of motion. Kinetic energy depends on an object's mass and its speed. Ignoring frictional losses, the total amount of energy is conserved. For a rolling object, kinetic energy is split into two types: translational, motion in a straight line, and rotational, spinning. So when you roll a ball down a ramp, it has the most potential energy when it is at the top, and this potential energy is converted to both translational and rotational kinetic energy as it rolls down. This leads to the question, will rolling objects accelerate down the ramp at the same rate regardless of their mass or diameter? You should find that a solid object will always roll down the ramp faster than a hollow object of the same shape regardless of their exact mass or diameter. This might come as surprising or counterintuitive result. A classic physics textbook version of this problem asks, what will happen if you roll two cylinders of the same mass and diameter, one solid and one hollow, down a ramp? The answer is that the solid one will reach the bottom first. In that specific case, it is true that solid cylinder has lower moment of inertia than the hollow one does. Although they have the same mass, all the hollow cylinder's mass is concentrated around its outer edge, so its moment of inertia is higher. But is it incorrect to say the object with a lower moment of inertia will always roll down the ramp faster? It takes a bit of algebra to prove, but it turns out that the absolute mass and diameter of the cylinder do not matter when calculating how fast it will move down the ramp, only whether it is hollow or solid. Applying the same concept, it can show that two cans of different diameters should roll down the ramp at the same speed as long as they are both either empty or full. The same principles apply to spheres as well. A solid sphere, such as a marble, should roll faster than a hollow sphere, such as an air-filled ball, regardless of their respective